For my problem, I am going to be solving a KenKen puzzle, also known as Math Doku. For those of you who don't know how these work, here are the rules so we can understand the problem. KenKen work very similar to Sudoku, but they involve math. So in similarity to Sudoku, each row and each column need to have each number one time, but Sudoku are always 9 by 9, whereas KenKen puzzles could be any size. They're always square. They could be 4 by 4, 5 by 5, 6 by 6, etc. And I've seen them be up to 9 by 9, but they could maybe even be bigger. But whatever size square they are, that is what digits you would use up to. So the example that I'll be doing today is a 5 by 5 puzzle, so we will use the digits 1 through 5. So for this puzzle, every row and every column will need to have the digits 1 through 5 used once with no repeats in a row or column. Another rule is that each bolded section must contain the numbers that utilize the indicated operation to result in the indicated value. So for example, in this section here, this section says 11 plus. So those three numbers need to add up to 11. Also, bolded sections may use repeated numbers as long as they are not in the same row or column. So, for example, in this section, depending on what ends up going here, it could be possible to have two 2s there because one is in one row and column and the other is in another. So it's okay to have them in the same bolded section. And then the last rule is that single bolded boxes are considered free spaces and tell you what number to put there, as seen here. We have a free space of 5 and 1. So the first thing we need to do now that we understand the problem is to devise a plan to solve. So for these problems, these are some strategies that I have developed over time that help me solve these puzzles. So I try to go through these, but I don't necessarily start with the same steps every time. So when I do these puzzles, I devise a plan based on what I see in the puzzle. So each time what I'll do is I'll look at the puzzle, I'll look at what I have, and I'll devise a plan based on that puzzle. So for this example, I'm just going to read through the bullet points of the things I look for as I'm making my plan. And then when I'm ready to carry out the plan, I'll go through those steps in an order that makes sense to me, and I might bounce around in those steps and go through those steps and hit them each multiple times. So these are the steps that I would go through. First, I will make a list of options to help visualize. What I mean by that is, since this puzzle is a 5 by 5, what I like to do is I like to just write 1, 2, 3, 4, 5 at the top. And the reason is I like to just see the numbers because I'm a very visual person. I like to see the numbers there at the top. So when I get to a certain section, I can see kind of like what numbers I have to work with to make that number. And so I'll show an example like that in a little bit. The next step, start with free spaces. Look for sections with uncommon values or values that can only be made with certain combinations of numbers using that given operator. Make notes in boxes. So if there's different combinations of numbers that could be used in certain spaces, but there's maybe only a couple different options, I'll make a note there so that I know when I come back to it later, or as I eliminate options, I can erase those and then narrow down the choices. Utilize sections that take up a lot of a row or a column, or a large portion of a row or column, and then fill in boxes that are left over. And while doing that, notice operations that eliminate certain numbers as choices. We'll see what I mean by that as I go through the puzzle. And be careful with multiple ways to fill in bolded sections, which I sort of mentioned a minute ago. So now that I've sort of gone through that list of things that I think about as I plan to solve, now I'm going to show how I would carry out the plan and solve this specific puzzle. So in my list of strategies, I always start with the free spaces, because obviously that's going to get me spots filled in. And then the next thing that I do is I go to that step of looking for sections with uncommon values. So for example here, +3, and here's where my list is helpful, even though this one's pretty simple. With 1, 2, 3, 4, 5, or really any n by n square, there's only one way to do +3, and that's 1 and 2. Now, I don't know which order they're going to go in, 1 and 2 or 2 and 1. So this is where we're going to just make a note that it will be 1 and 2 in some order. And I'll come back to that later because I don't know what the columns look like yet. Now I see also that here I have almost this whole row taken up by 8 times. And again, here's where visualizing my numbers helps me. I've already used 5 in this row. So with what's remaining, the only way to make 8 by multiplying 3 numbers together is 1 times 2 times 4. 3 is not even a factor of 8. I don't know how those are going to fill in that space, but what that does help me realize is that 3 is the only remaining number in that row that's left as an option. So that's here in the steps of look for sections with uncommon values and utilize sections that take up a lot of a row, and then fill in boxes that are left, and notice operations that eliminate certain numbers as choices. So kind of putting a few of those strategies together. Okay, now another sort of uncommon one, or a number that only has so many options in this example is 40 times. Because I know with my math sense that 40 is a much bigger number, and with 1, 2, 3, 4, 5, there's only so many ways I can get that. So I'm going to start with 5. If I divide 5 out of 40, I am left with 8. Well, I don't even have 8 as an option in my choices. I can make 8 though with the numbers that I have. I can do that by doing 2 times 4. There's no other way I can do that. Now, if this box was bigger, if this section was bigger, I could even break it down further. I could do 5 times 2 times 2 times 2 if this box had a 4th square in it, but it doesn't, which means that if we're thinking of this as sort of a factor tree, we've broken it down as far as we can go. So 5 times 2 times 4 is the only way that we can break down that breakdown times 40. Now still, I don't have an idea yet of where those numbers are going to go. So right now, we're just going to leave that alone. Let's start to look at the rest of our box. Let's start to look around. I'm going to use the 5 as a starting point because that 5 was given to me and the 1 was also given to me. So I'm just going to use that row and that column. The freebies are a great way to use context clues, right? They're given to you for a reason. So if you can look at those and see how can those help me if you get stuck. So let's look down next to the 1. In the bottom row, we have 12 times. There's only one way to do that with our numbers, and that is 3 times 4, because this is a 5 by 5. Again, this is a reason why I love making a list up here. If I had a bigger puzzle that went up to 6, I'd have more choices, right? I could do 2 times 6. I still don't know which order they'll go in, so I'll make a little note for myself. Now what that leaves me in this row is I still need a 2 and a 5 in this row. So what I like to do at this point is play around with, could I put them in either spot that's left over? Well, if I wanted to put the 5 right here, I can't do that because there's already a 5 in that column, which means the 2 must go here and the 5 must go here. And now if we look over at our section with the 40 times, that means that the 5 cannot go in either of these 2 squares. It has to go in this square. And the 2 and the 4 must then go here. And notice now we're starting to eliminate and starting to fill in more choices and narrow down where things are. Let's keep going. I'm going to now look back up here at the 1, 2, 4. Well, 2 and 4, neither of those can go here because even though I don't know which of these 2 boxes is the 2 and which is the 4, I for sure know that they're both in that column. So I'll figure out which is which later, but no matter what, they'll be preventing a 2 and a 4 from being in this top corner, which means that that top corner has to be the 1. And so the 2 and the 4 will go there and there. I'm just going to make these a little smaller. And actually, a similar situation is right here. One of these will be a 2, which prevents this one from being the 2. That means this one is the 4, and this one is the 2. Notice we have gotten a lot, and we haven't even been doing it for that long. Look, we almost have a complete column. The only number we're missing in the column now is 3. So that is going to go in this square. And now with the addition of that 3, we almost have a complete section. We want those 3 squares to add up to 9. We have 5 plus 3, which is 8, which means this needs to be a 1. And I am just doing these steps in the order in which the things pop out to me. There is no one correct path or order of steps that you would have to do this in. I always recommend starting with the free spaces, although you technically don't have to, but you could do things in really an infinite number of orders. Again, it just really depends on what you start to notice based on the patterns that you're seeing. So for me, I just did the 1. Now I am going to look up and see that that prevents a 1 from going right here in the 3 plus section. That means the 2 has to go in that left box, and the 1 has to go on the right. And then right above that, that means the 2 can't go here, so the 4 has to go on the left, and the 2 has to go on the right. Then, if we work our way back down, we can see that we have another almost complete column. Again, the only number we're missing is a 3 again. So that bottom number will be the 3, and then the 4 is what its pair was to make 12. In the next column over, we're missing 2 numbers. We're missing, looks like we have a 1, a 2, and a 4, and so we're missing a 3 and a 5. Now, sometimes we won't have what we need, but actually we already have a 3 and a 5 in each of the rows to help us figure out where the next 3 and 5 must go. So we can see a 5 is on top and a 3 is on the bottom there, which means the 3 and the 5 in this 2 minus box. That means the difference between our two numbers is 2. The 5 has to go on the bottom, and the 3 has to go on top. Look, we are almost done. We're about 60% done, a little more. All right, what should we do next? Well, let's take a look at this box here that says 2 divide. This means that the 2 numbers divide to equal 2. Now, knowing what we know with 2, and again, let's take a look back up at our list. This one, we have to be careful. We never know which is the first number and which is the second number. So when we're working with division, we have to be careful because it could be 2 divided by something is 2, or something divided by 2 is 2. So we actually have 2 different options for what could go in that second box, 4 or 1. Now, if I was addressing this section earlier in my puzzle, I wouldn't know which it was going to be, right? I'd have to make a note for myself because it could be either or. But because I did other parts of my puzzle first and then got to this section, I already have a 1 over here, so that eliminates 1 as the option. So 4 is going to be the correct choice there. Okay. Let's see, what should we do next? Let's take a look. So up here, we have 11 plus. So I need these 3 numbers to add to 11. So let's just take a look at what we have here. All right, I need them to add to 11. I already have 3, which means the other 2 need to add to 8. And then let's take a look at that row. That row is missing a 3 and a 5. Well, that's good because the 3 and the 5 do add to 8. So that checks out. If they didn't, we'd be in trouble. And notice one of them is a 3, and I already have a 3 in this section, which is okay, but I can't have a 3 in the same column. So that means that the other 3 has to go diagonal to it, so I don't double up. And the 5 would have had the same issue. So we have this situation where we've got diagonals. It's okay to have repeats in a bolded section, but no repeats in a row or a column. So we're done with that one. And now we're on to our last section, and we have a column that's almost done. This column is just missing a 1, it looks like. So let's go ahead and put that in there. And that 1 is part of a section that says 8 times. So we want all 3 of those to multiply to 8. Well, dividing out a 1 still leaves us needing 8. And so let's take a look. Let's just look at the 2 rows. In this row, we're missing a 4. And in this row, we're missing a 2. And those multiply to 8, which is awesome because, again, if they didn't, we would be in trouble because those are our last 2 numbers, so they definitely need to satisfy that condition. Otherwise, we made a mistake somewhere. And now you'll notice that we have filled in all of the squares. Now, what I am very careful to do as I do these puzzles is I'm always checking as I'm filling in a box. I'm always looking left and right and up and down to make sure that I'm not putting a number in if that row or column already has that number. But as part of our problem solving process, we should still do the look back step and make sure that our puzzle is not only complete, but is correct. So let's just go ahead and take a moment to do that since it won't take too long. Let's check the rows first. So the top row, 1, 4, 2, 5, 3. 4, 2, 1, 3, 5. We're just checking for no repeats. 2, 5, 1, 3, 4. 3, 5, 1, 4, 2. I said them in the wrong order, but that's okay. 5, 3, 4, 2, 1. Good. So no repeats in any of the rows. Let's check the columns. 1, 4, 2, 3, 5. 4, 2, 5, 1, 3. 2, 1, 3, 5, 4. 5, 3, 1, 4, 2. 3, 5, 4, 2, 1. Great. No repeats in any of the columns. Now let's just make sure our math worked out. Well, we've got our free spaces, so that's great. 3 plus 5 is 8, plus 3 is 11. 4 times 1 is 4, times 2 is 8. 4 divided by 2 is 2. 2 times 4 times 1 is 8. 2 plus 1 is 3. 5 minus 3 is 2. 4 times 2 is 8, times 5 is 40. 4 times 3 is 12, and 5 plus 3 plus 1 is 9. So that's great. We finished our puzzle and we did everything correctly. Awesome. So what I wanted to show here with this puzzle is how we can use this to practice the problem solving steps, but I also wanted to show and talk about why I use these with my students. These puzzles are amazing for practicing algebra skills, specifically factors. As you can see here when I was doing the times 40 section, they're great at breaking down numbers and seeing the factors of numbers, seeing how numbers are what they're made of, right? Especially as you get into some bigger puzzles, 6x6s, 7x7s, right? You know, you could get a section with a times 288, right? And the section might be like this, just as I made this bigger than I needed to, but the section might be like that, right? So you have 6 squares there that multiply to 288. And there's so many ways you could do that with, who knows, maybe this is from a 1x6 or a 1x7 or even a 1x8. And so there's a lot of options there. And so it's just a great way for students to practice their skills with factor groups and multiplication, division. It's just great for that baseline practice with those skills that really help them then build up to those higher level skills that we're working on in Algebra 2 and other classes that I teach, but mostly Algebra 2 is the group that I'm working with. It also, like I said, works on specifically the problem-solving process and critical thinking. And they're just fun, and you know, we want our students to have fun in our classes too. So I don't do these a lot, like I don't do these every day or anything, but I try to build them in when I need an extra warm-up, or I just have a day where I need something extra for students to do, like a day where I just need something extra at the beginning of a unit maybe, or whatever. They're just great fillers for when you need something to give to your students. So hope you enjoyed my video. Thank you so much for watching.